Good morning, students. Today we are going to find the Laplace transformations of some more functions, or we will apply the Laplace transformation to evaluate some integral problems. First, we have to prove that integral 0 to infinite j0x minus cos x upon x dx is equals to log 2. First, we will have to prove this result that integral 0 to infinite j0x minus cos x upon x dx is equals to log. If we take fx is equals to j0x minus cos x, if we take fx is equals to j0x minus cos x, then we know that Laplace transformation of fx with respect to p is equals to Laplace transformation of j0x minus cos x with respect to p. If we take this one as fp, then fp is equals to Laplace transformation of j0x with respect to p minus Laplace transformation of cos x with respect to p. As we have earlier proved that the Laplace transformation of j0x is 1 upon under root of p square plus 1, and the Laplace transformation of cos x is p upon p square plus 1. So, if we take the Laplace transformation of the fx, that is the Laplace transformation of j0x minus cos x as fp, then fp is equals to 1 upon under root p square plus 1 minus p upon p square plus 1. As we have earlier proved that integral 0 to infinite fx upon x dx is equals to integral 0 to infinite fu d. This is obtained by taking the Laplace transformation of fx upon x, and by taking p tends to 0, we get the result integral 0 to infinite fx upon x dx is equals to integral 0 to infinite fu d. So, if we apply this result, then we get integral 0 to infinite j0x minus cos x upon x dx. This is equals to integral 0 to infinite fu. Here we have find that fp is equals to this one. So fu is equals to 1 upon under root of u square plus 1 minus u upon u square plus 1 d. If we integrate the right hand side, we obtain that this is equals to 1 upon under root u square plus 1 upon under root u square plus 1. If we integrate this one, then we get it as log u plus u square plus 1. Log of u plus u square plus 1 under root. This is the integration of 1 upon under root u square plus 1 minus u upon u square plus 1. If it is integrated with respect to u, then this is equals to minus 1 by 2 log u square plus 1. And the limits are from 0 to infinite. If we put these limits and solve this one, we get it as log of u plus u under root 1 plus 1 upon u square minus 1 by 2 log of u square into 1 plus 1 upon u square, and the limits are from 0 to infinity. If we solve this one, we get log of u plus log of 1 plus under root of 1 plus 1 upon u square minus log of u minus 1 by 2 log of 1 plus 1 upon u square, and the limits are from 0 to infinity. So if we solve this one, we get this is equals to limit u tends to infinite log of u and log of u are cancelled. We get log 1 plus under root of 1 plus 1 upon u square minus 1 by 2 log 1 plus 1 upon u square, and the limit u tends to 0 comes to be 0. So if we put this limit u tends to infinite, we get it as log 1 plus 1, and all the rest terms comes to be 0. So this is equals to log of 2. So integral 0 to infinite j0x minus cos x upon x dx is equals to 2, which is the required result. If we take the another problem, we have to prove that if the Laplace transformation of the function fx is equals to fp, then we have to prove the Laplace transformation of integral 0 to infinite x raised to u fu upon gamma of u plus 1 du with respect to p is equals to f log p upon p. The solution of this problem: we have to find the Laplace transformation of integral 0 to infinite x raised to u f of u upon gamma of u plus 1 du with respect to p. By the definition of the Laplace transformation, this is equals to integral 0 to infinite e raised to minus px integral 0 to infinite x raised to integral 0 to infinite x raised to u f of u upon gamma of u plus 1 du dx. If we change the order of integration, changing the order of integration, we get this is equals to integral 0 to infinite f of u upon gamma of u plus 1 into integral 0 to infinite e raised to minus px x raised to u dx, and then integrate with respect to u. The middle integral 0 to infinite e raised to minus px x raised to u dx is the Laplace transformation of the function x raised to u. So we use the definition of the Laplace transformation. We get it as integral 0 to infinite f of u upon gamma of u plus 1, and the Laplace transformation of e raised to x raised to u is gamma of u plus 1 upon p raised to u plus 1 and d. The gamma of u plus 1 is cancelled here, so we get this is equals to integral 0 to infinite f of u upon p raised to u plus 1 b. If we solve this one, then we get this is equals to 1 upon p integral 0 to infinite p raised to minus u f of u d. If we write p raised to minus u in this form, 1 upon p integral 0 to infinite e raised to minus of log p e raised to, if we write this one as e raised to minus u log p f of u d. If we write this integral in the form of the Laplace transformation, then we get this is equals to 1 upon p integral 0 to infinite e raised to minus log p into u f of u d. If we compare this by the definition of the Laplace transformation, then it is 0 to infinite e raised to minus px fx dx. So p, the parameter in this case here is log p. So this is nothing but it is equals to 1 upon p f of log p, which is the required result. In the another problem, we have to prove that integral 0 to infinite e raised to minus x sin x upon x dx is equals to pi by 4. Here we also apply some results of the Laplace transformation, which shows that first we can let here, if you let fx is equals to sin x, then the Laplace transformation of fx is equals to fp. So here fp is equals to Laplace transformation of sin x with respect to p, and this is equals to 1 upon p square plus 1. So we will find the Laplace transformation of sin x, or rather fx upon x with respect to p. As we know that this is equals to integral p to infinite fu d. So here fx is equals to sin x. So Laplace transformation of sin x upon x with respect to p is equals to integral p to infinite fu is 1 upon u square plus 1 p. If we integrate the right hand side, we get the Laplace transformation of sin x upon x with respect to p is equals to, if we integrate right hand side, then it is tan inverse u, and the limits are from 0 to infinite. So the right hand side is equals to tan inverse infinite minus p minus tan inverse p. So this is equals to pi by 2 minus tan inverse p. So the Laplace transformation of sin x upon x with respect to p is equals to pi by 2 minus tan inverse p. But by the definition of the Laplace transformation of sin x upon x with respect to p is equals to integral 0 to infinite e raised to minus px fx that is sin x upon x dx. And here we have calculated that this is equals to pi by 2 minus tan inverse p. So in this case, if we put p is equals to 1, then integral 0 to infinite e raised to minus x sin x upon x dx is equals to pi by 2 minus tan inverse 1, and tan inverse 1 is equals to pi by 4. So this is equals to pi by 2 minus pi by 4, which comes to be equals to pi by 4, which is the required result. So we have used the Laplace transformation to calculate some integral equations. Thank you very much.